When we're calculating confidence intervals for means, either we know the population standard deviation sigma or we don't. So that's going to lead to two different types of calculations. The formulas are very similar, but we're going to learn a new distribution. When we know the population standard deviation, we can use the normal distribution similarly to how we used it in finding confidence intervals for proportions. But if we know the population standard deviation, we likely already know the mean. If you recall back to chapter 3 in how we calculated the standard deviation, we had to know the mean. So why would we estimate the mean if we already know it? So the section on estimating a population mean when we know the population standard deviation, we aren't going to prioritize that. Instead, we're going to look at the case more deeply where when we take a sample from a population, we don't know any parameters. We don't know the mean, we don't know the standard deviation. Since we only can obtain a sample standard deviation from our sample, there's a lot more variability in our answers. When we calculate the margin of error, instead of using the normal distribution, we're going to use the student t distribution. Here's an image borrowed from Triola's elementary statistics. In here, the blue curve represents the standard normal distribution, and the red and the yellow curves represent student t distributions with different degrees of freedom. And we'll expand a little bit more on that later. Essentially what the t distribution is a family of distributions based on essentially our sample size. So every sample size has a different t distribution that we'll associate with it. And if we're using the sample standard deviation, especially when the sample size is small, usually less than 30, we need critical values that are bigger than what we would get from the normal distribution. The origin of the student t distribution comes from the brewer, Guinness, in Ireland, who was hiring mathematicians for quality control of their product. William Gossett was a mathematician who was hired by the Guinness Brewing Company right at the turn of the 20th century. Gossett took a year off from his job at the brewery to go work with Carl Pearson at his lab. Now, Carl Pearson is one of the big names in statistics. He developed a lot of statistical tests that we use. And so Gossett took a sabbatical, spent a year with Pearson at his lab, and worked out the math. He figured out this law of errors for small samples and ultimately developed this distribution. It's called the student t distribution instead of Gossett's distribution because Gossett really wanted to publish it. He was so excited about his work, he really wanted to get it out there and share it with the world. But Guinness didn't want him to. They were making lots of money off of this notion that he's created of quality control with the samples of the ingredients they were using. And they did not want to share that secret. They were afraid if the secret got out, their competitors would catch up to them. The Guinness manager said, "Okay, Gossett, you can publish, but just not under your name." So he created a pseudonym, and that pseudonym was A Student. It turns out that one distribution becomes pretty powerful in the context of confidence intervals and in the next chapter, hypothesis tests. So this is a pretty big contribution to the field of statistics. Some characteristics of the t distribution. The distribution is similar to the standard normal because it is bell-shaped, it's symmetric, the mean, the median, the mode are all equal to 0 and located at the center, and the curve never touches the x-axis. But the t distribution differs from the standard normal distribution because the variance is greater than 1. The t-distribution, we've already said, is a whole family of curves based on the concept of degrees of freedom, which is directly related to sample size. And as the sample size increases, the t-distribution gets closer and closer to the shape of the standard normal distribution. Degrees of freedom are defined as the number of values that are free to vary after a sample statistic has been computed. And we'll see different degrees of freedom as we progress through the class, depending on what we're doing. So it is important to pay attention because that's going to tell us which curve in the family we need to use. We use the symbol df to indicate degrees of freedom. And for a confidence interval for the mean, the degrees of freedom are given by the sample size minus 1. So if n is 15, degrees of freedom would be 14. We just subtract 1 from it. When we only know the sample standard deviation, we need to check that the sample is a simple random sample and that n is greater than or equal to 30, or the population is normally distributed if n is less than 30. So we need a normal distribution for our population. The margin of error is here. And notice we have a t alpha over 2 instead of a z alpha over 2. S is our standard deviation, and n is our sample size. The confidence interval, you can see that margin of error popping back into the confidence interval calculation. The corresponding Excel formula to calculate the margin of error is also the same as Google. So confidence.t, our alpha, which is 1 minus our confidence level, our sample standard deviation S, and then size is just n. So we don't even use the degrees of freedom when we're calculating using this technology. They are the same in Excel and Google, which is awesome so far. Everything's pretty consistent. The formula, though, the corresponding Excel formula returns the margin of error. So we have to manually add and subtract that margin of error from the mean in order to find our confidence interval. And we'll see that in a subsequent video. There is a formula for sample size for mean estimation. We have to assume we know the population standard deviation because of the increased variability with the t-distribution. We'll take a look at that example as well in another lesson.